what is electricity basically, right? Before that, we forgot one thing, right? Screen walkthrough. So this is screen walkthrough, and if you, the session you are seeing here, the screen you are seeing over here, you can click on raise hand. You can click on raise hand to raise your hand and ask the doubts, ask particular doubts or particular topics regarding current electricity to itself, right? Chalo. So this is the section, right? So perfect. All right. Current electricity. What are charges? So we start with study of charge, right? We start with study of charge. So let me take another pen. So we are starting with the study of charges. What is electricity? Basically, it is study of charge. What is current? What is no, not actually. What is current? What is current? If you go into the basics, what is current? Basically, current is anything which flows. It is current. For example, you might have gone to waterfalls. That is also current. That is a current of water. As simple as that, right? So anything which flows is a current, right? What is electricity? Anything which is flowing, and that flowing thing is electron, right? So we call that as current electricity, right? Right, like for example, water current, we say water current. So there is a flow of waters, right? If tennis ball is being flowing, so it is a tennis ball current. So if electrons are flowing, it is electric current, as simple as that, right? So what is electricity? What exactly is are charges? What exactly is moving charge or static charge? What is the difference between them? So in today, like today's session, or in your 10th standard, you're studying about a moving charge, that is current electricity. When you study about a static charge, that is known as electrostatic, that we will study in 11th, basically 12th standard, right? If in case or at all you take science, so you'll come across it, right? So what exactly is positive and negative charge? The charge acquired by a glass rod when rubbed with the silk is called positive charge, and the charge acquired by a ebonite when rubbed with a wool. See, this is a very typical example, so I'll go with an easy part, right? Okay, so there are two type of charges, like one is positive charge and one is negative charge. What is positive charge and what is negative charge, right? uh, Basically, charge is the internal property of of an atom, right? Like atom has got electrons, like my body has got tissues, so atom has got electrons, uske body ka structure hai. So that electrons, probably what does happen in an atom, electrons may go and may come, for example, in this room people may come and people may go, right? So if you are coming inside, you're gaining electrons. If you're going outside, you're losing electrons. So that is what is the meaning of. See, there is nothing like positive charge. There is always either there is excess of electrons or lack of electrons. There is nothing like there is nothing like a positive charge. We have just to represent it, to represent the lack of electrons, we say that it is a positive charge or nothing else, right? So that is what is positive charge is all about. Basically, it's all about electron, because there is only one thing exists, that exists is electron. Electrons exist, nothing else exists, right? So when I'm talking about electrons and protons, protons is the absence of electrons, electrons is the presence of electrons. That's it. ठीक है, absence of electron मतलब positivity है वहां पे, and presence of electrons means negativity है वहां पे. Therefore, electrons are negatively charged and protons are positively charged. What is the unit of charges? It is coulomb, right? And what is the value of charge? It is 1.6 into 10 to the power minus 19, right? Perfect. So static and current electricity. What is conductor and insulator? So I'll explain it to you over here. What is conductors and insulators? So let me get to this point, right? So conductors and insulators, right? I'm going to give you a very basic differentiation between them, and trust me, you'll never forget it ever in your life. Every atom in this world contains positrons and electrons, right? Positive charges and negative charges. Either it be either it be conductors or insulators. Every one contains this positive charge and a negative charge, right? So, what is the difference between this conductors and insulators is that in conductors there is no movement of protons. If you understand it, there is no movement of positrons, whereas there is nothing as protons or positrons. But just to understand, there is no movement of protons, there is only movement of electrons. There is only movement of electrons. Electrons are free to move in conductors. And what is insulator? Insulator is something in which neither protons neither electrons can move. Therefore, because electrons can move, conductors conduct electricity and insulators do not conduct electricity. That is a very basic difference between conductors and insulators, right? That is a very, therefore every metal is a conductor. Why? Because every metal has a tendency to move the electrons, whereas non-metals do not have the tendency to move the electrons. Therefore, that is the basic difference. Metals conduct electricity, whereas non-metals do not conduct electricity. Getting it? So that is the basic difference. I'm talking about the motion of electrons. यहाँ पे in conductors there is a motion. That means electrons are free to move. Whereas यहाँ पे there is no motion. There is no motion of either of electron or proton. There is no motion. And here is only motion of electrons and there is no motion of protons. Just understand that. That is the basic difference between conductors and insulators. So let's come back. A substance which allows passage of electric charges through it easily is called conductor. And a substance which has infinitely high resistance does not allow electric current to flow through it. It is known as insulators. For example, rubber, glass, plastic, ebonite, etc. are this. So what is current? Okay, let's come back to this point. Okay, so now we will see this. What we will see? What? Let's wait. Just give me a second. Okay. Do you see this? Right. These are known as electrons. So these are the flow of electrons. We'll come to know about it. We'll study about them. We'll just give me a minute or a second. We will come back to this part. Right. Okay. I'll come back to this. First, let's understand what is electric charge. What is electric charge? What I'm going to tell you is here. What I'm about to tell you is electric various physical quantities. Okay, we are about to study various physical quantities, right? Various physical quantities. We are about to study various physical quantities, out of which the first physical quantity is electric charge, which we just studied. They are of two types: positive charge and negative charge, right? So what is the second thing? The second thing is current. What is current? What is current? Current is nothing but rate of flow of charge. For example, what is it? It is known as rate of flow of charge. Let me give you an example, right? So let's assume that it is a conductor. It is a conductor. Okay, it is a conductor and current is passing through this conductor. Sorry, I'm so sorry. Okay, and let's say there are electrons in this conductor. There are electrons in this conductor. Okay, or charges, electrons or charges, whatever you call it. So in this particular section, let's say this section is d distance d का जो section है, let's assume this particular section of this conductor. In this particular section, the number of charges, for example, let's say here there are 100 charges, for example 100 charges. So in this particular section, ये the rate of flow of मतलब 100 charges in per second in 1 second or 100 charges in 1 second. right? That is known as the rate of flow of charge. What is the amount of charge that is flowing through this distance within a second is known as rate of flow of charge. That is known as current. That is known as current, right? So what is current? What exactly is current? The rate of flow of charge, right? So current is exactly what is current? Current is rate of flow of charge. So what is current? I is equals to rate of flow of charge. या फिर charge per unit time and the unit is amperes, or in bracket you can say coulomb per second. Coulomb per second or amperes is the unit of this current. ठीक है? What is the next section? Next thing we study about potential difference. What is potential difference? I'll give you a better example of potential difference. I think a lot of people don't understand what is potential difference. Well, it is very easy. For example, right, if I take this bottle and I drop it, where is it going to go? It is going to go down. Why not up? No, for a very simple reason. आप कहोगे gravity. Okay, perfect. That is gravity. ठीक है. So potential does work in gravity. That is true because there is a potential, there is gravity, therefore it has potential. If the gravity was zero, there wouldn't have been any potential, obviously. But what do you mean by a potential separately? Other than gravity, what do you mean by potential? What is potential? Matlab anything which wants to move from higher level to lower level. For example, uh, temperature. कभी भी always and always a ice will always try to come at the room temperature. A boiling water would always come down to room temperature. 100 degree would always come down to 27 degrees Celsius. 0 degree will always try to come to 27 degrees Celsius. What is that? यानी कि temperature is flowing from high temperature to low temperature and temperature is flowing from low temperature to high temperature. What does that mean? Anything which is flowing from higher temperature to lower temperature, that is known as potential, right? Anything which flows from higher value to a lower value, it may be in terms of temperature, it may be in terms of energy. Why I'm talking about this is because over here, let's assume this: a water is being filled in this container till this height, and these two containers are connected, and in this container water is only filled till this height. Where do you think water ka flow hoga? Obviously this direction, because it has more water and it has more energy because it is at a more higher height as compared to this. So it will flow until it comes to the same level. So jab tak, until and unless both water levels are same into it, water will flow. So it will be known as water current, and this difference is known as high potential ka difference. This is known as potential difference of water. So what do we understand by the potential difference of electric current in electric current? Yes, Mohammed, you can ask your question in the comment box on the left side, I think. Okay, fine. True. So getting it. So what exactly is potential? This is potential difference. So what does this mean in electricity? In electricity, what does that mean? In electricity, what it means, I'll again explain it to you with a simple example. I'm coming up with a simple example. Understand this. It is a building. It is a building. There is a building of this height. Okay. Let's say this building is of 10 floor, 4 floors, 4-floor building, 4 floor. And here we have a building of 3-floor building, third floor, building till third floor, third floor. Been me. ठीक है. So here it is. Uh, the thing is कि here, right, here it is a guy standing over on the 4th floor and he wants to jump to this floor. Let's assume these two buildings are very close. These two buildings are very close. ठीक है. So let's suppose this guy wants to jump from this building to this building, right? Okay, this guy was on fourth floor and he wants to jump to this building. So what is the potential difference? The potential difference will be given as the work done by this man to jump from this building to this building is known as the potential difference of this guy. That will be the potential he has. Potential, how much potential do I have to jump from this building to that building? In a very basic thing, we understand that this is what is the meaning of potential, like how much energy or how much potential do I have to jump from this building to that building. Therefore the work done to jump from this building to that building by this electron, if I consider this electron or this charge, this charge, the work done per unit charge, or per charge, there if there would have been 10 charges, the work done by the 10 charges to jump from this higher potential or a higher value or a higher building to a lower building or lower value is known as the potential difference or the potential of that particular charge. So how is this charge defined? This charge is defined as this, or do I say it in a different manner? Let's say, let me say this in a different manner. So what do I say? This is a battery, and let's say this is the current flowing in this part. So let's assume that 10 ampere of no, sorry, the charge here is of 10 coulomb, the 10 coulomb, and work done in this circuit, let's say work done in this circuit is given to be as 100 joules, is given to be as 100 joules. So what will the potential difference? The charges here are 10 coulomb, as in there are 10 charges, for example. So what will be the potential difference? It will be work done per unit charge, which is known as 100 by 10, which will be given as 100 by 10, that will be 10 volt. So the voltage of this battery will be 10 volt. So the voltage of this battery will be 10 volt, right? Okay. So that is the potential difference. That is what you are known. That is what is the potential difference. So basically, we come down to resistance. Basically, we come down to resistance. What is resistance? What is? Okay. अभी तक what we have seen what is charge. Okay. Again, I think we have seen what is current. We have seen what is potential. Right. Now we are going to see what is resistance. What is resistance? Right. So what exactly is resistance is in a conductor, right? For example, in a conductor, there are many number of electrons. There are many electrons, positrons, a lot of things, or many number of atoms are present in this electrons. So if a current at all wants to flow from this conductor, it will get a lot of resistance from these electrons. Do you understand this? They will get a lot of resistance from these electrons, a lot of resistance, a lot of resistance, a lot of resistance. Getting it? So what exactly is going to happen? This is known as resistance. That means, this current is being stopped by these atoms. They will stop. Okay, you cannot go from this area. This is, it is very difficult. Either you have to jump over me or you have to go from around, like that of resistance. So that is known as the resistance of a material, and it depends material to material. There may be many more number of atoms, many more number of positrons, and they will give more resistance to the coming electrons or the coming charges. That is known as the resistance, and it totally, ठीक है ठीक है तो ये totally depends on resistance, totally depends directly proportional to the length. If the length increases, just assume if the length is increases, the resistance will increase. Why? Because there will be more number of, for example, if I am going through a tunnel, and if the tunnel is much more longer, I'll get more resistance from the incoming water, right? Let's assume those waters are the atoms which are coming towards me. If I want to crawl into that tunnel, I'll get more resistance. What is the way I can reduce my resistance? If the area increases, if I get a more area, the resistance will decrease, right? So therefore, if you understand this, yeah, okay. If you understand this, you will understand this as well. that resistance increases with decrease in area. Therefore, resistance is inversely proportional to area. Do you get it? So after combining these two parts, we get a formula for resistance. And that formula comes out to be this, right? Also, what do I see? Okay, this is the formula for resistance, right? Before I'm coming to that formula, I also want to come to this formula. We have talked about this part as well, right? We have talked about this part as well. We have talked about current. We have talked about potential. So what do we see? As soon as I increase the potential, the current gets increased. Therefore, potential is directly proportional to current. This is what I have seen. Also, came across as right, the potential upon current, the value of potential difference upon current comes out to be constant, right? Comes out to be constant, and that constant is known as resistance. And this is how we calculate resistance, and this is how we calculate resistance, right? Do you get it? We have seen in a particular circuit, which is the particular circuit. Let me also bring you the circuit inside. Okay. If you understand, in this circuit, right, basically in this part of the circuit, if you see in this part of the circuit, the current, what is the direction of the current? Obviously, this side is the direction of the current. This is the direction of the current, right? Why? Because current flows from negative charge to positive charge. So current flows like this. Getting it? Yes or no? No? Yes. So current flows in this direction, right? Current is flowing in this direction. From charges will move from high potential to low potential. Current moves in the opposite direction. Therefore, it will move in this direction. All right. So this is the direction of the current. So what we have seen in this particular circuit, the value of the potential difference is 9 volt, and the value of the current which comes, the ratio of potential difference and current will come out to be always constant, and that will be equal to the resistance given by this particular wire. This wire is the metal wire, right? This wire is the metal wire, and metal have conductors inside them. Therefore, the electrons are flowing from this conductor. Do you understand? This metal has this wire is the metal, the copper, the same copper which we use inside our home, right? जो हमारे home, the wires we see, which we plug, or which we see which is running through our house, that is the wire that is made up of copper, which is insulated from an insulating material, so that the current or the electrons do not come out, or we don't get shock out by touching them. Getting it? So that is the reason. They get insulated. Why insulated? Because insulators are the bad conductors of electricity. They do not conduct electricity. Therefore, electrons will not, or the current will not come out of the wire. Therefore, it is insulated with that wire. But inside it is metal, copper metal, which has electrons. So as soon as it gets the potential difference, the electrons start running. Therefore, current is produced, and that current in that particular circuit, the potential difference, that is the battery, the potential of the battery, which you can see 9 volts here, that potential difference upon the current in the circuit is always constant, and it will come out to be the total addition of the resistance. So in this particular question, the total addition of the resistance is 3 10 plus 5, which is 18 ohm. So the ratio will be equals to 18 ohm in this particular question. So in this question, the ratio will be equals to 18 ohms, right? Not 3, 10 or 5 individually, but the total addition. So that is how we calculate resistance. The Ohm's law is V by I equals to constant. So this is also known as Ohm's law, right? So this is also known as Ohm's law. So this is also known as Ohm's law. So right. This is also known as Ohm's law. What is Ohm's law? The ratio of potential difference to current in that given circuit is always constant. That is equals to resistance. That is Ohm's law. As simple as that. How do you calculate resistance? Now I'm coming to that point. So we just saw that the resistance is proportional to two things. Resistance is first of all proportional to length, and resistance is proportional to 1 by area. If you combine these two, you get resistance is proportional to length per unit area. And if you remove the proportionality sign, you have to add a constant. So that constant will be rho L by A. So this is the formula for resistance. If you want to calculate the resistance, get the length of the wire, get the area of the wire, get the resistivity of the wire, and put into this formula, and you will get the resistance of that particular wire, right? So this is how you, so this is the numerical method to calculate resistance. The physical method, the practical method is get the ratio of potential difference and current, right? That is also a way to get the value of potential difference. So if at all you have given potential and current, you will find out V by I. Say R equals to rho L by A, then you can find out the rho also if the length and area is given in numericals. So it is very easy numericals. All right, so let's come back to this. What else do we see? Array. All right. Right. So we also want to know what is parallel circuit, and why do metals conduct electricity? Because they have free electrons, right? So if they have given a potential difference, like here it is given higher building, it is given lower building, it is given a lower building, or a higher energy, a higher potential, and a positive potential, a negative potential, right? Positive is the higher potential, negative is the lower potential. Positive is the higher potential, negative is the lower potential. Positive higher, negative lower, positive higher, negative lower. बात समझ में आ रही है? Positive higher potential, negative lower potential, right? Also, let me tell you the sign conventions as well. Let me also get you the sign convention. I don't know how much of you people know about the sign convention, but even if at all you have any doubts, let me get it cleared right away. ठीक है? So this is the let's say 10 volt battery. Current always, electrons will flow from higher potential to lower potential. Electrons will flow in this direction. So this will be the direction of electron. This will be the direction of electron. This will be the direction of electron. Electrons have negative charge. Therefore, electrons के direction का opposite होता है current का direction. The direction of current is opposite to the direction of electrons. Therefore, in this same question, the direction of electrons is going to be opposite. बात समझ में आई? है ना? Let me draw in the same diagram only. The direction of electrons are going to be this direction. The direction of electrons are this. The direction of electrons, or direction of electron will be this. समझ में आया? Did you get it? Electron will flow from higher potential to lower potential. Electron will flow from higher potential to lower potential, but current flows opposite to the direction of electrons. If you want to by heart by this technique, electrons are negative, therefore current wants to be positive, it is flowing in the opposite direction. That's it. This is the basic technique to remember. It is not the real explanation why current is being taken in the opposite direction. The explanation is very, basic explanation. It has got no logic into it. It was just accepted like this way. That was the explanation of this. The current has to be the opposite direction of flow of electrons, right? What is electrons flow? What is current? Flow of electrons only, but we take it in the opposite direction, right? Sure, perfect. I think the sign convention is very, very clear. Very, very clear. I think so. If you have any doubts, do ask me. Okay? Chalo, let's come back to this point. What is series and what is parallel? Doubt? Hai? Yes, everyone has a doubt. I'll get you a very basic definition of what is series and what is parallel. So, series as in, okay. Series as in, I have a bulb. I have this bulb. Again, I have this bulb. Again, I have this bulb. It is kept after one after the other. Okay, and this is the current flow. So this is known as series combination. This is known as series combination. Just look at this. What do you mean by series? Series means the current is going to be same. The current is going. Is there any way that current can reduce? Huh? Is there any way that current could get reduced? For example, if there are thousand of electrons or positrons going in this direction, thousand positrons, they will also go from this point to this point. They will also go from this point to this point. They will also go from here to here. So all the thousand positrons, is there any way for them to get out of the circuit? No, right? So therefore, the current is going to be constant. The current is going to be constant in the series combination. The current is going to be equal. Do you understand this? The current is going to be equal. 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 ये समझना जरूरी है. तो current equal होगा. That means by the formula of V equals to IR, V by R equal होगा, यानी कि V1 by R1 has to be equals to V2 by R2 has to be equals to V3 by R3, like that. Do you understand? This is equals to current I. ये बात समझ में आती है क्या? आती है ना? Right? नहीं आती. Right? So what is V1? V1 is this for, this is the V1, right? No, it does not decreases. How can the flow flow is not affected by the voltage, right? Flow is not, if the volts of the bulb are different, then the flow of electrons decrease or not in the circuit, they will not decrease, right? In the circuit they are not going to decrease. There are different voltage. I'm going to show you. Let me show this once again. They are different. Okay, they are different. Let's say this is a bulb, right? We represent bulb as resistors. Okay, we represent bulbs as resistors. So here the potential will be V1, here the potential will be V2, here the potential is going to be V3. The resistance is R1, here the resistance is R2, here the resistance is R3. But the current is going to be same. I, the current is going to be I, the current is going to be I, the current is going to be I. Because current is a scalar property, right? How can it get divided? It cannot get divided, right? So what is the current in this particular section? I. And what is that current? What is that current? That current is going to be V1 equals to IR1. So I is equal to V1 by R1. Did you get that? Understanding? So that is the beauty of physics. That is the beauty of this series combination. That current will be common or the same throughout, but there will be difference of resistance. Resistance may be different, may be same. I can take all the three resistance same, or I can take it different. Potential difference is going to be different. Got it? So this is the series. Now let's see the parallel wala. What do you mean by parallel combination? What do you mean by parallel combination? Like to this same point and this same point which is connected to this circuit, I distribute these three sections in three different parts. I distribute them in three different paths. So the current which is coming, the current will see, oh, I have three different ways to divide. So current will go I1, I2 and I3, right? Current को क्या देगा? Thousands of electrons are coming, positrons are coming. What they will say, I have three ways. They will always choose the easier path. Okay, 300 of them are going this direction, 400 are going this direction, 300 are going this direction. So they separate it out. So therefore current distributes. If current is distributed, but what do you see? This is the higher potential, this is the lower potential. Therefore the potential difference between these two will be constant. Therefore potential, if this is V, this will be V, this will be V, this will be V. But why? Because understand the difference. let's say this. Let's say this. If this was 10 volt, so this would have been the higher potential 10 volt. This would have been the lower potential 0 volt. Yes or no? So at this point, this point, this electrons, all the 1000 electrons got a different resistance. So यहाँ पे value गिर के 7, the value came down to 7. Let's suppose they got another rejection, the resistance. So the value came down to 4 volt, right? And here they got the another value of resistance. They got more resistance, so it came down to 0 altogether. So therefore their potential difference is different. See, यहाँ पे the difference is 3, यहाँ पे it is 3, यहाँ पे it is 4. Let's suppose it came down to 4.5. So the difference is 2.5. यहाँ पे difference is 3, यहाँ पे difference is 4.5. So the potential difference between 2 points is always different because they get different resistance. That is why the difference is different for them. But in this case, what is happening? What is happening in this case? The potential difference between this point, let's suppose this is also 10 and this is 0. For this particular circuit, current is traveling through this path, right? So for this path, the potential difference is 10 to 0. So 10 minus 0 is 10. And for this path, again, the higher potential is 10, the lower potential is 0, therefore 10 volt. यहाँ पे again it is 10 to travel to this point, it is again 10. So in all the three resistance or all the three value of bulb which is being held there or the resistance, the potential difference is the same. Did you understand this? क्या ये समझ में आया कि नहीं आया पहले बताओ? Yes or no? Did you understand this or not? ठीक है, I hope things are getting cleared. I hope things are getting cleared. Let me see, do I have a... Yes, I do have. Chalo, let's see once again. Parallel combination. I am going to discuss it one more time. ध्यान देना सब लोग. देखो यहाँ पे क्या हो रहा है. Understand this. This is 12 volt battery. So this is 12 volt. So therefore this is also 12 volt because there is no resistance. Do you see? This is also 12 volt because there is no resistance. This is also 12 volt because there is no resistance, but here there is resistance, here there is resistance, here there is resistance. So it was 12 and it is 0. ठीक है, तभी तो potential difference is coming out to be 12 at this line. Again here there is no resistance, 0. Again no resistance, 0. Again no resistance, 0. So in this, what is the potential difference? For this particular resistance, the current is coming from here. What is the potential difference? 12 minus 0. It is 12. What is the potential difference for this particular resistance? It is 12. What is the potential difference for this particular resistance? It is 12. So what do we see? In a parallel combination, the potential difference remains same as that of the battery. But in series, it does not remain same. Got it? Yes or no? Okay, perfect. Chalo. Yes, there would have been a difference. There would have been a difference if there was a resistance here. If there was a resistance here, there would have been a difference, but there is no resistance in this particular part. Therefore, the potential difference remains same. Understand this. Understand this. If there was a resistance, then there would have been a potential difference from 12 to, let's say, this would have been 8. If there was a resistance, there would have been, then 8, then it would have been 8, then it would have been 8. So there would have been a different, understand this. So getting it? All right. What is the next thing? Heat. The next part is heat. In this chapter, the next part is heat. Let's come to heat. What is heat? Let me see, do I have anything for heat as well? So do you see there are number of electrons in this part, right? There are number of electrons in this part. So there also will be atoms in this big difference. there will be atoms, right, with which they will be colliding, there will be collisions. So obviously if these electrons are moving, if this electron is moving, it is carrying some kinetic energy with it. Did you understand this? Obviously the kinetic energy is the energy of motion. If this electron is moving, it is carrying some energy with it, so that energy is known as kinetic energy. And once it goes and collides to this atom, as soon as it collides, due to the, by the law of conservation of energy, this energy should convert into some other form. It is not possible. Energy can neither be created nor be destroyed. Energy cannot be destroyed. It can only be converted from one form to the other form, right? If you heat a water, does that get water energy from anywhere else? No, it is getting energy from the gas. How is gas hot? Because you have lighted the gas. You've given a, what do we say, a fire to the gas. So that gas had an energy inside the cylinder. The cylinder is highly packed, highly pressurized. It contains energy, right? So if you give a light to it, it will burn. So energy is converting from one form to other form. Getting it? So that is how energy do not get destroyed ever. It does not get. The heat energy converts into vapor energy. The water which is boiling, it is boiling, it is converting into liquid to vapor form, and it is going into the atmosphere, and it is going somewhere else. It is in the form of other energy, vapor energy, like that. So it is never destroyed. So this energy, kinetic energy, will be converted to the other form. What is that other form? Right? Potential is given to be work done per unit charge. Right? Right? So this energy which is converting, do you also know that work done, heat? Okay, you also know that this V equals to work per unit. This work done is also the unit of work done and heat are equal. The unit of heat and energy are equal, right? They have different physical significance in different situations. In this situation, this work done is in the form of energy, and this energy is known as heat energy. Therefore, here I can write potential difference is given to be as heat energy per unit charge. In different situations, we can change W, E, and H with different forms. Getting it? All right, so let's see what exactly is energy. What exactly? Okay, so let us see this. So heat can be given as potential into charge, and potential can be written and charge. We just knew that current is known as charge per unit time. Therefore, current can be replaced as current into time. Did you get this? It is very simple. Now I'm going to make you by heart this, right? What is VIT? Do you see this? This is a VIT. This is VIT. This is VIT. VIT is a college in South India. So you can actually get this, that South India is very hot place, therefore VIT, right? So heat, whenever you need to get the formula is heat is VIT. It is VIT. Why? Because VIT is a college known as Vellore Institute of Technology, and it is in South India. It is a quite hot place in South India. That is why H is equals to VIT. You can just buy hard. It's not necessary, but yeah. Okay. So this is what it is. All right. So let's right. So let's see other forms of the formula. Let's also see the other forms of formula. Right? Heat is equals to VIT, right? Can I write this V as IR? Array V is also equals to IR, na? Right? Ohm's law. So can I substitute this over here? So I'll get I square R into T. See, I just converted this formula. This can also be converted as, right, I can be written as V by R, therefore it can be written as V square by R into T. Do you get it? So these are the three different forms. These are the three different formula. You can also note it down if you want. These are the three different formulas for heat, right? This is the three different formulas for heat. These are the three different formulas for heat. All right, so we'll come to a new page and we will see what is power. What is power? Power is nothing but heat per unit time is known as power. Heat per unit time is known as power or energy, or you can say rate of change of energy, or I can say rate of change of energy. Matlab within a second how much energy is getting consumed or getting converted is known as power. Simply the rate of change of energy per unit time. So we just saw in this case energy is heat energy, and we just saw three formulas: VIT upon T, which will be V into I, which will be V into I, which will be what? V into I, right? So power is given as V into I. So if I write this V as IR, it will become I square R. If I write this I as V by R, it will become V square by R. So again, there are three formulas for power as well, right? V into I, V square by R, I square R. These are the three different forms of power that can be represented. All right, so what is the next? All right, so we also come across this small doubt: what is ammeter and what is voltmeter? So let's also see what is ammeter and what is voltmeter. It is very simple quite. So ammeter is given as ammeter and voltmeter is given as voltmeter. So we only know it is ammeter is a ampere, so that is current. Ammeter measures current, voltmeter measures voltage. By the name itself, now, how do you remember? Ampere is the unit of current, so it is ammeter, right? And volt is the unit of potential difference, so therefore it is voltage. So voltmeter जो होता है ना, it is represented as circle में B like this, and ammeter is represented as circular in A and like this. So this is how ammeter and voltmeter are represented. This is how they are represented. Now the bigger question: when do we use ammeter, in series or in parallel? Where do we use the voltmeter, in series or in parallel? Where do we use it? That is the bigger question that comes in mind. That is the bigger question that comes in mind. So I have a better solution for that. I have a very easy solution for that. In fact, I have a very easy solution. Do you want to know it? Yes, you would want to know it, and it is a very easy method which you can understand in a very basic manner. Let me just get the this thing, this thing. All right, perfect, perfect. Do you want me to make it much larger, even larger? Okay, perfect. ठीक है, चलो, ठीक है. See, यहाँ पे क्या होता है? What happens here is current is flowing, right? Current is flowing from here. Current is flowing. So current is flowing from this part. Current is flowing from this part. If I want to measure current, what measures current is ammeter. So obviously बात है, I need to keep ammeter here, because if it measures current, so therefore it has to take current from here, it has to run from it, and it has to send it out here. So ammeter is connected in series. Ammeter is connected in series. Did you understand this? Why is ammeter connected in series? Because ammeter measures current, or current can be measured in this way only. How does voltmeter is getting connected? See, I just told you this point is the higher potential, this point is the lower potential. That is only how current is flowing. So this will be higher potential and this will be lower potential. Let's say this is going to be 7 volt, and this is going to be 3 volts. So this is the potential difference. So voltmeter will need to be connected to a higher potential, and then it need to be connected to a lower potential. Therefore, it is being connected in parallel with the resistance. Did you understand this? Did you understand this? By any means? By any means, did you understand this? No. Yes, you did. Okay, now voltmeter is getting connected in. Voltmeter gets connected in parallel, and ammeter gets connected in series. समझ में आया कैसे? It is the easiest way out. This is the higher potential part. This is the lower potential part. Voltmeter wants to get connected to a potential parts only. So it will connect to a potential higher, and it will connect to a lower potential between these resistance. So it will get the potential difference, right? So therefore, it has to be in parallel situation only. It has to be in parallel. So how do we conclude this? So ammeter connects in series. Voltmeter connects in parallel. Did you get this? Right? ठीक है? ठीक है ना? So how did we get learn this? A S V pass. I need a pass, which is very urgent to me. V pass, VIP pass. I need a VIP pass, right? B is for P, A is for S. I need a VIP pass. I need a VIP pass. I need a VIP pass. So potential difference in parallel, emitter in series. So I need a VIP pass. I need a VIP pass. Right? Very simple. I think this is the most silliest technique, because you can only remember the silliest and funny techniques. You cannot remember the serious techniques. You need to make it very like I'm a very important person. I want to visit a school. I want to see is resistance connected, is emitter connected in series or parallel? Does the teacher know it or not? So I need a VIP pass. I need to get into a school and to check it out. So I need a VIP pass. Why do I need a VIP pass? So that they would also know that even I know that emitter is being connected in series and voltmeter is connected in parallel. I need a VIP pass to get into a school for checking and all. Okay, so this VIP pass tells you what? That voltmeter is connected to parallel and ammeter is connected to series. As simple as that. So you will remember. What was the first formula? The first formula was VIT, Vellore Institute of Technology. VIT is in South India, therefore it is very much hot in there. So heat ka formula is VIT. H equal to VIT. H equal to VIT. As simple as that. ठीक है? चलो. What else? Ohm's law हो गया. Resistance covered. Factors on which resistance depend is rho into L by A. So that is also covered. Equivalent resistance. Okay, in series you add them, like in series you add them R1, R2, R3, and in parallel you add them by 1 by R1 plus 1 by R2 plus 1 by R3, like that. That is the difference between that. Law of resistance in parallel, again same, current remains, current is distributed, so we do it like that. Joule's law of heating is known as exactly what I told you. What is Joule's law? It states that, okay, it states that what is Joule's law of heating? Sorry. Achha, it will not work at all. Okay. What is Joule's law of heating? Joule's law. Okay, will pen work? Nothing will work. So state that heat produced, right? So it states that heat produced in a conductor is directly proportional to the square of the current through it, I square RT, proportional to the resistance, I square R, and the time for which the current is passed, I square RT, I square RT, I square RT. The other form of VIT. V की जगह मैंने I am keeping I into R, therefore it becomes I square RT. It becomes I square RT, right? So what else? What else do we see over here? What else do we see? Current, electric energy, electrical power is nothing else. What? Kilowatt per hour. ठीक है, kilowatt. Power is what? Watt or kilowatt per hour. ठीक है. All right. Mind map. you want to copy this, you can copy this. You can take screenshots. I'm giving you some time. If you want to take a screenshot, you can actually take the screenshot. Okay. Right, you can take the screenshot of this: electric power, electric energy, potential difference, electricity, Ohm's law, Joule's law, right? And this is the resistance, resistivity, resistance in series. So this is the mind map. You can actually go through it if you want. I'm giving you 10 seconds. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. If you want to take a screenshot, you would have already taken it. If you want to take this screenshot, take it. Right, I'm leaving the screen for a few seconds. All right, I think we have covered almost everything from my side. I think this is the maximum topic which comes across. And do we have anything after mind map? We don't have formative assessment, question papers, like that. So if you need question papers, you can anytime contact Genext, right? You just contact or mail us. We will get back to you with the question papers. So right, so thank you so much guys for joining in for revision classes. I'm sure your revisions are going superbly well. If you have any doubts, any queries, get back to this contact number, right? If you have any queries, do contact us, because we have expert faculties here and you will get a super personal attention. You'll get one-on-one counseling as well, right? And you will get all your doubts cleared. It may be in any subject, it doesn't matter. So just get in touch. And thank you so much again for attending the class. And this is the number you need to get in touch with: 810-805-3700. That is the WhatsApp number of Genext. Do get in touch. And this was the third session of this physics lecture. And the fourth session will be magnetic effects of electric current tomorrow. The current electricity which we studied today, the effect of this electricity on magnetism. How does it affect magnetism? That we are going to study tomorrow, right? So all the very best to you guys. Superbly well, do well, and if you have any doubts, do contact us. Chalo, see ya. Bye bye.